Howdy, this is your friendly neighborhood physics teacher here, and we're going to talk about potential energy. So, if you think about the word potential, potential means it can do something. It hasn't done it yet, but it can. And another way in physics, potential energy is another way to think about it, is stored energy. So potential energy is stored energy. Most common type of potential energy that we talk about is gravitational. Gravitational potential energy. Basically, what gravitational potential energy is, if this is the ground, the higher something gets, the more potential energy it gains. So it's affected by height. Height, it's its number one item it deals with. So potential, yes, it uses we use U for potential in AP Physics. So your gravitational potential energy equation, mass plays a part. Of course, your acceleration due to gravity plays a part. And then your height plays a part. Your gravitational potential energy is measured in joules. Your mass is measured in kilograms. Your G, as long as you're on Earth, is 9.8 meters per second squared. And then your height is measured in meters. The reason Y is height, think about your axis. So you have your X axis, then you have your Y axis. This is your vertical axis. So anytime you're going vertical, up and down is height. Your X is your horizontal. So anytime you're going side to side would be X. That's all it is. Just kind of giving you if you're going up and down, left or right. Your 9.8 meters per second squared, all that is kind of saying is, so if you have a ball, you're going dot, 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 every second that you're going, so from here to here is 1 second. From here to here, again, is 1 second. Ooh. And from here to here is 1 second. If you start out with a velocity of 0 meters per second, in 1 second, you're going to be at 9.8. Because basically what that's saying in meters per second. So you're increasing, each second, you're increasing your meters per second by 9.8. So you're getting faster, you're increasing your velocity each second. So this would be 19.6 meters per second. This would be 29.2. Yes, 29.2 meters per second. Right? No, now I'm second guessing my last one. Hold on, can I do math? I can't type it in the calculator, that's for sure. Jeez Louise. 0.4, not 0.2. 2 points off. Okay, or 0.2 off. So that's all it's saying. So each second, you're going to increase your velocity. So that's all that, it's just a rate. That's all that gravity is. It's telling you that you're speeding up. So your gravitational potential deals with height. Another thing is dealing with relationships. So we know that this is constant. So that's never going to change. But what happens to your potential energy if your height increases and your mass stays the same? So basically, you've taken this ball like here, and you've just increased it. what would happen to your gravitational potential energy? Hopefully you said it would increase, and that is a direct relationship. We could do the same thing with mass. So again, our gravity is constant. That's never going to change. We're going to say our height stays the same, but we pick a bigger object. What's going to happen to your gravitational potential? Hopefully you said that it's going to increase also. That's also a direct relationship. This one doesn't necessarily make as much sense because don't necessarily know if it's possible to do, but again, gravity would stay the same. Let's say we're somehow able to keep our universal gravitational the same. No, I know how this would work. I am challenging you in a lab to keep the gravitational potential energy the same. And I want you to increase the mass. To keep your gravitational the same, what would you have to do with your height? Hopefully you said decrease. This is called an inverse relationship. It's called an inverse relationship. If one goes up, the other goes down, and vice versa. And of course, all these, same thing, if you decrease the height, you decrease. So it just reacts the same. It does whatever the other one's doing. And then when it's flipped opposite, it's an inverse relationship. The next type of potential energy we deal with is elastic. Is elastic potential energy. Now, elastic potential energy deals with anything that stretches. So it could be a rubber band, it could be a slinky, it could be a spring, it could be your skin, anything that stretches. And you have your elastic potential energy equals 1/2 little k x squared. Your U, E is just your elastic potential energy. It's energy, so it's always measured in joules. K is your spring constant. Yes, they call it, you can also call it elastic constant, but most everyone calls it a spring constant, even if you're not dealing with springs, even if you're dealing with rubber bands or your skin or stretchy pants, it's still a spring constant. This is a unique constant. Unique constant. Basically what that means is, let's say you're comparing my stretchy pants to your stretchy pants. They're going to have a different coefficient, a different spring constant. If you go to one rubber band to another, they're going to have a different spring constant. One slinky to another. It's very specific to that object. So it's not like gravity, which is always 9.8. It's constant for that object. It depends on that object. Your x is your distance from your equilibrium. Distance from equilibrium. And I will draw you something to kind of show what I'm talking about. The best way to do it is using a spring. So you have a spring that has a mass on it. Let's say I pull the spring to stretch it out. The distance between here and here would be your x. Because if this is at equilibrium, this is like if you just put the mass on the spring and let it stretch out and it's not moving, that's happy. So it's happy here. Happy. It's stressed here because I'm making it, stretch out. It'd be the same thing if I scrunched it somehow. If I was able to scrunch it. All right, your x would still be here. And it's still not happy here. It wants to be in equilibrium. and your x is a distance, so it's measured in meters. Your spring constant is Newton per meter. And that deals with anything that stretches. So that is a quick overview of potential energy. Hopefully that helps. Have a good day. Bye.